retailer. Are you doing okay?
Not really. Kind of just overwhelmed and really feel like I can't handle my stress.
I feel that. Have you tried using an Oura Ring or an Apple smartwatch to help you out? I heard those could help.
Yeah, those are good ideas, but honestly, I can't really afford it right now.
Yeah, I totally get that. Would you like to try something I've been working on my team?
Sure. What do you have?
I've been working on this. It's a smartwatch for mental health. It takes your physiological information from 2 sensors that calculates your BPM, SpO2, and activity in real time. As long as you have Wi-Fi, you can transmit your data and receive the current time and notification alerts right on your wrist. And it's not $300, and you don't have to pay a monthly subscription like the other brands. Here, try it on.
Firmly place the sensor on the top of the forearm. Then feed the strap through the Velcro loop and tighten down till snug.
Create an account on our Smart Health app and verify your email.
This smartwatch is built around an ESP32 S3 reverse TFT feather with a custom designed printed circuit board. The platform integrates 2 sensor subsystems, a MAX 3101 optical photoplethysmography PPG heart rate, and a peripheral oxygen saturation SpO2 sensor expansion module, and a BMA 250 modular triaxial MEMS accelerometer evaluation board. The ESP32 S3 performs real-time pre-processing of raw, red, and infrared PPG signals, as well as 3-axis XYZ accelerometry data via the I2C bus SDA-SCL. These signals are processed to compute heart rate and BPM, peripheral oxygen saturation SpO2, and activity classifications of standing versus walking. Process telemetry is transmitted over 2.4 GHz Wi-Fi to a cloud-hosted backend, where it is read by a machine learning interface and smartphone application for higher-order analytics and visualization. The outside enclosure consists of a custom-designed 3D-printed watch housing. The front face features embossed Texas A&M and Team 33. The color TFT display on the front has the current time, BPM, SpO2, and anomaly detection status. Time and anomaly notifications are transmitted through Wi-Fi from the Firebase cloud. Animations are also on the front display for heartbeat and walking/standing. The heartbeat is programmed to match the current BPM, and if the accelerometer reads fast enough movement, the screen will read a walking man instead of a standing one.
We created LSTM autoencoder machine learning model. We designed it, trained it, and implemented with 89% point-to-point accuracy for a grouping neighborhood of 4, including transient behavior. Our sensor to average to analysis, our average time was 100 milliseconds. We overcame multiple things, such as global averaging in favor of a smaller regional average, overcame sensitivity, and we also created a exportable TF Lite model that successfully ran on artificial and human data that's recorded on the Firebase. More details about the machine learning model: we use a 64-bit encoder that forms a Gaussian distribution from our decoder. When we go from encoding to decoding, we have MSC reconstruction error. And if the MSC reconstruction error is above 87% percentile of the Gaussian anomaly, we produce an anomaly flag. We have 128 layers, inside of which 64 are unsupervised layers. And we have 50 epochs. Our exported TF Lite model has 1 megabyte that runs in real time on the Firebase. That can be run on different platforms of phone and browsers. We also use a neighborhood of 4 points, assuming normalization input, and a final training loss of 0.1187. We also have measurements relative to the Apple Watch. So for sedentary calculations, we are within a range of 5 BPM with a confidence of 80% to 73% per point, and we have 100% confidence within 5 BPM range. And with a high exercise index, we are within 5 BPMs, 65% of the confidence interval. And when we are within 10 BPM, we're confidence interval between 87% and 92%. This is a per point accuracy comparison for each second. We created a Wi-Fi duplex communication with lossless transmission, and also have remote control of the ESP32 with intendable data paths controlled wirelessly over Firebase and the UI. We connect to TMU IoT via a WPA2 protocol. For signals, we have success/failure criteria that is on both ends, from ESP32 feedback and also from the Firebase. So we have message bits, send bits, and fail bits that we can check, and error messages. And we have a robust system for catching all fatal errors and restarting. So far, we've not had any fatal errors during runtime. Some errors were the sensors disconnecting. We immediately are notified of that, and the only thing we have to do to fix that would just be restarting the device. And the times of occurrences of those were roughly 3 of the 100 times we were running it for extended of 10-minute period. We have the Firebase database. We get initialized data paths, information from the Firebase, information UID start/stop commands. We have get last log for debugging for retrieval from error paths. We can send the output of all command/pass/fail. Also, for sensor error codes, if it's not connected or if we lose connection, we can see that on the ESP32 side and from the server side. So we can send a notification saying just to restart it.
The Smart Health app includes a streamlined create account process where you have to create an email, password, a username, age, and your name. You will not let you log into the app unless you have verified your email, and if you have forgot your password, it includes a forgot password process. Once logged into the app, you'll be directed to a health dashboard page where it displays your current heart rate, any anomalies determined by the machine learning algorithm, and current SpO2, all real time. From there, you can select heart rate variability, SpO2, breathing, meditation, and music. Breathing, music, as well as meditation all include audio walkthroughs to help you breathe and meditate through these exercises, as well as including written breathing and written meditation exercises on top of that. Heart rate variability, heart rate, SpO2, and movement all include statistics about your heart rate throughout the day, your heart rate variability, your movement, total movement time throughout the day, and your current SpO2, as well as information about how you can improve them. The project also includes a delete account process where it will direct you to enter in your password and delete your account when selected.
Hey,
How's the stress level, Taylor?
great. This device really works.
Awesome.
I finally have a way to deal with my stress before it gets too overwhelming.
That's great. Well, gig 'em.
Gig 'em.